and compounds using the rules developed by the IUPAC, the International Union of Pure and Applied Chemistry, in order to come up with a consistent system so that chemists all over the world could communicate with each other and it would be easier to name compounds once they came into existence. So we're going to go through your nomenclature package. We'll try to get through parts A and B in this video. In part A, you're simply told that you have to learn how to name elements, and you simply name the elements by looking at the periodic table and naming them as you see them. So if you go in your periodic table and you look for Fe, let's just say, so let's go to our periodic table right over here. We find Fe, we see it's iron, it would be called iron. You need to know elements 1 to 36 plus the other elements highlighted over here. Now we're going to go to part B and take a look at how to name binary ionic compounds. Binary ionic compounds are ionic compounds, so metal and non-metal, that are made up of, well, two different elements. That's what the binary means, two different elements. One is a metal, one is a non-metal. So for example, here we have sodium chloride. We have a metal and we have a non-metal. When you're given the formula of a binary ionic compound, you have to follow three main rules. The first rule, or the first step, I should say, is to name the metal. So you go look in your periodic table to find Na, and you see that the metal is sodium. So you name it sodium. The second rule is to find the name of your non-metal. Name it chlorine. So Cl is my non-metal, chlorine. But what you need to do is you have to modify its ending. The INE ending becomes IDE. So chlorine becomes chloride. Don't change the ending of the metal, only change the ending of the non-metal. And your last step really is putting them together. So you have sodium, chloride. These steps apply to all the binary ionic compounds that you'll see that contain monovalent elements, and you'll understand what that means when we get to the next few parts. We'll do a few more examples together to make sure you understand the rule. Basically, just name the metal, name the non-metal, change the ending of the non-metal. So we're going to try this one over here, CaN. So our metal is calcium. Our non-metal is nitrogen. You don't change the ending to nitrogenide, you change it to nitride. Some of them are pretty intuitive. Chlorine becomes chloride, fluorine becomes fluoride. Some of them you need some experience with, like nitrogen becoming nitride. Let's try this one over here, AlO3. So again, name the metal. What you should be doing is you should be practicing this before I actually do it and then compare your answers. Aluminum. And then name the nonmetal and change its ending. So oxygen doesn't become oxygenide, it becomes oxide. Let's try this one here, BAP, Ba3P, 2. So Ba is a metal, barium. Our nonmetal is phosphorus. Phosphorus does not become phosphoride, it becomes phosphide. Make sure you're very careful with your spelling because one letter different can mean a whole different compound. If you put a T here instead of a D, that becomes a different compound altogether. So be very careful with that spelling. You should be able to complete the rest of these practice problems using the rules above. Make sure you follow the example and follow the rules and practice them. It's the only way you'll do this without making mistakes. Now we're going to go take a look at how to make a formula from a name. So I'm going to show you two methods for how to make a formula from a name. I'll show you the crisscross method and the charge balancing method. So suppose I gave you the name sodium oxide. You know it's a binary ionic compound because it's made up of a metal and a non-metal. So in the crisscross method, what you do is you write down the symbol of the ions. So we have the sodium ion, which is Na plus 1. How do I know it's Na plus 1? Well, I go to my periodic table and I look at what group my element's in. Sodium is in group 1. It has 1 valence electron. So it would rather lose that valence electron than gain 7 to get up to 8. It's easier to lose than to gain. And you can see over here the charge written down is plus 1. Some periodic tables will give you that, others won't, so you should know how to find the charge even if you didn't have it in your periodic table. If something was in group 2, there's 2 valence electrons, it would rather lose 2 than gain 6. So it would be plus 2. When you lose electrons, you become positive. Electrons are negative. They're like negative thoughts. You lose negative thought, you become a more positive person. If you were in group 17, you have 7 valence electrons. So if fluorine has 7 valence electrons, it's easier for fluorine to gain 1 electron than to lose 7, so it would become negative 1. So again, you should review how to find the charges of ions so that you can do the crisscross method. So Na is plus 1, O is minus 2, because it's in group 6, needs 2. Easier to gain 2 than it is to lose 6. Circle the charges in crisscross. Bring the plus 1 from the sodium down to where the oxygen is on the other side, and bring the negative 2 from oxygen down to the sodium on the other side. And the end result is you get Na 2. Don't write the charge symbol, just put the number O. Now I'm not going to put the 1. When there's a 1, you don't have to write it down, it's implied. We wouldn't write O if there was no O there. So we just put O, and if there's a 1, you don't have to write it in. So what this formula tells us is that there's 2 sodium ions for every 1 oxide ion present. That's the crisscross method. You could also do the charge balancing method, where your goal is to get an overall charge of 0. So in the charge balancing method, you just start off writing the ions side by side. So Na is plus 1, O is minus 2. You want to make sure that this compound overall is a charge of 0. Right now, there's plus 1 and minus 2. That's minus 1. So you need to add an ion to make it overall 0. If you add an oxygen, it'll be too negative, or it would be more negative than you want it to be. So let's add a sodium. When we add a sodium, we have plus 1, that's plus 2, minus 2, that's 0. So this is the way to make the compound of a charge of 0. You need 2 sodiums and 1 oxygen, so you can simply write that you have 2 NAs and 1, I should say, oxide, because it's not the oxygen atom, it's the oxygen ion, the charged one. So you'd say oxide. As you change the ending, you change the ending to "ide." So that was the charge balancing method, and this over here to the left was the crisscross method, and you can choose to use whichever method you like. We'll do one more example. We'll do the example of magnesium oxide. So write down the charges of the elements, or the ions rather. So we have Mg plus 2 because it's in the second group, and O minus 2. We're doing magnesium oxide right now. You can do the crisscross. If you did charge balancing, it would already be done. You have plus 2 and minus 2. It's already 0, so you just need 1 magnesium, 1 oxygen. It's MgO. But let's do a crisscross. When you do your crisscross, you get Mg 2O with another 2 here. For ionic compounds, there's another step called reduction. You need the simplest ratio between the 2 elements. So if you can reduce, you need to divide. So here I need to reduce by dividing by 2 and dividing by 2. As long as they're multiples of each other, I can reduce. You can't have fractions. So if you have 2 and 3, you can't reduce anymore. So when you reduce, you get MgO. You're only going to reduce for ionic compounds, not for covalent compounds. And this ends our video.